having me. Good morning, everybody. The next 30 minutes, I'll try to explain where we're at when it comes to autonomous vehicle. We are much closer than most of you think, but it's very complicated. We will expose it to you. 4 years ago, when I was approached by one of the founders of Mobileye, told me, we would like you to join the team. We are going to cure an epidemic problem of the human race, car accidents. So I said, yeah, right. You want to solve it, but being an adventurous person, I said, okay, I'll join it. I joined this team, and I'll show you that after a few years of, almost 20 years of development, we are really getting close to it. So who needs autonomous driving and who needs those safety features into vehicles? 1,250,000 people are dying every year from car accidents worldwide. 20 to 50 million people are getting seriously injured, and between 1% to 3% of the GDP of a country, or an OECD country, goes on the cost of car accidents. Those are the recent numbers that are happening in Germany. Over than 3,000 people are dying from car accidents. This is not an act of God. This is causes because of the human factor. 90% of the car accident is because of us. Homo sapiens are bad drivers. Sorry to say it. I know in Germany it's not a popular saying. But most of the research talking about that autonomous vehicles can reduce the rate of accident by around 90%. You cannot guarantee absolute safety, and there are moral issues about robotic vehicles driving near humans. I will approach this topic also during the presentation. Few words about the company. Mobileye is an Israeli-based company, founded in 1999 out of the huge startup scene that happens in Israel. Some of you probably know that. Between 1999 to 2007, we had 0 sales, only development. And the development, the proof of concept, or the aim was to prove that the vision sensor, together with a strong algorithm behind it, is able to detect and to understand the driving scene better than humans. The concept in the industry back then was it's not possible to do that. You need few types of sensors. But in 2007, 8 years of R&D, so for the startups here, you still have hope, okay? 8 years, no sales. In 2007, Volvo was the first customer of Mobileye. In 2014, after having few customers in the OEM industry, we went to an IPO, which had the biggest IPO ever in the Israeli economy, $5.7 billion, and the 10th biggest of a tech company in the world. In 2017, last year, we were acquired by Intel. Now we're an Intel company for $15.3 billion. In 2021, together with BMW, we're going to launch the first Level 4 autonomous vehicle on the road. So our business status today is that we work with 27 OEMs. We have around 80% market share when it comes to assistance systems. The last few years, we won 100% of the tenders of the industry that we attended to. So what we provide to the industry is we are able to detect with a vision sensor everything which is relevant for driving. Detection of pedestrians, detection of vehicles, of traffic sign, traffic light, landmarks, all of them with accuracy of 99.99% in average. And we are doing that worldwide in every condition of road, every culture of driving globally. This is the basic capabilities towards autonomous vehicle. The next slides, I'll start to talk about autonomous vehicle, and from having this ability to understand everything on the road towards autonomous vehicle, the road is very long. It's very complicated, much beyond the sensors. So ADAS, Advanced Driver Assistance Systems, take you up to level 2 when it comes to the industry terms. From level 3 and up, we are already talking about semi-autonomous and autonomous vehicles. Our approach and strategy is to use our building blocks, to have economic scalability. It cannot remain a science project, and you need to formalize safety. Autonomous vehicles must be transparent to the regulators and to the audience. If it's not transparent, it will never be on large scales. When I say transparency, I'm talking about the transparency of the AI technology. So our 3 pillars is to have sensors around the vehicle that understand everything, as I showed you before. You need crowdsourced mapping. You need HD maps. GPS maps are not good enough for autonomous vehicle. I will explain why. You need semantic driving policy. You need to put human skills, human negotiation skills of driving into the algorithm. And on top of that, you need transparency and to formalize into a mathematical formula the human common sense and to merge it into the algorithm. So let's start with the sensors, the basic ability, 360-degree. We use the camera, the vision sensor, as the primary sensor. We will use in the future in our project LiDAR and radar only for redundancy for safety. Okay? Why we need vision sensors? The streets are designed for humans. Humans are using their sensor to understand the street. With your vision sensor, you understand 3 types of data: static data, dynamic data, and semantic data. And all of those can be done only by a vision sensor. A radar and a LiDAR will be used at the Mobileye approach only for redundancy for the vision sensors. So how it works, you can see here 12 cameras surrounding the vehicle. We are looking in all distance of relevancy of driving in 360 degrees, for the left, for the right, from behind, and using our semantic ability to understand the roads. The next pillar is the crowdsourced mapping. Why we need maps in the car? We humans, when we drive, we don't need a map to drive. We need it also for redundancy to the sensors in the unique situation when the sensors will not understand what they see. We need a memory in the vehicle. We humans drive with a memory of the road or memory of the experience of driving. And it's crucial for having the localization and planning of the driving. So how we do that? We harvest the data, we aggregate the data in the cloud, and then we send the data to the vehicle for localization. So how we harvest the data? We are leveraging our unique position as the main supplier of the industry for ADAS. So those ADAS systems are able to prevent accidents, but in second hand, to send relevant data. We do not scan the road. We only send very narrow layer of information. We only collect relevant dots, lanes, boundaries, reflectors, lampposts, traffic sign, traffic lights, and we are sending that to the cloud. We are not interested in the next McDonald's branch on the road to send you a coupon. We only send relevant data using 10 kilobytes per kilometer. So we don't need even changes in the communication infrastructure. We are not waiting for 5G. So after the GDPR regulation, I must address that. We, of course, anonymizing the data. We don't care from which car it came from. And we're encrypting the data. This is how the data looks like. It's not readable. Nobody can read that, only our crazy developers. And then the data is being aggregated, creating HD crowdsource. We have 27 million vehicles already using Mobileye. In the next years, we will have much more than that. This is eventually how it looks like. We take a layer of map, a map platform, and we are enriching that with this data. So after enriching the data, we are able to localize the vehicle in a very accurate way, 5 centimeters of accuracy. A GPS, the best GPS, can localize a vehicle between 5 to 10 meters. So this is how it looks like. On the right, you can see the car driving autonomously, and you can see the dot in the video on the right. Those are the dots that given us the reference exactly where the car is. Why we need that? Again, for redundancy, for safety. In the situation that the car will need additional information, which will be very rare, we are able to add data to the car. On the left side, what you see, it's a fusion between the data that was collected by ADAS systems before that and the sensor in the vehicle. So we are fusing the data of the map and the sensors to make sure that we didn't miss any type of information on the road which is relevant for the autonomous car to drive. It already works. I'll show you later on how it works in an autonomous car today, not in 10 years. So we harvest the data, we aggregate the data, and then we are sending map tiles to the car, and eventually we are able to localize and to use that for planning of the driving. Using narrow bandwidths, 10 kilometers per driving. The implementation is being done today. By the way, the first place, first places that we have started to do that, it's in around Düsseldorf in Germany and in Japan, together with Nissan. In Germany, we are doing that with our own retrofitted systems. I'll talk about them. The local accuracy is very accurate. It's in real time. Privacy, it complies with the GDPR. It's anonymized and encrypted. And we are leveraging our position in the world of advanced driver assistance system. The next building block is driving policy. When you drive, you negotiate. We negotiate with human intuition. When I want to bypass you, I don't call you saying, hey, I want to bypass you. We are negotiating, and we are using our experience, our brain, and our intuition. And this is something that you need to teach an algorithm to see, to understand. Because in the next 20, 25 years, we are going to have robotic cars near human drivers. So the robotic car must be able to classify the environment. Is this kid is running? Is this car will cut me? Is this driver is an aggressive driver or a courteous driver? And this is a very, very complicated task. What we are using, deep learning at Mobileye, we are teaching the software to come with conclusions out of details, rewarding the software when it takes good decisions, and punishing the software when it takes bad decisions. And we are teaching that for billions of scenarios of driving, so afterwards, the software in real life is able to come with decision-making on a human level, only safer. Another example, we are using this scenario many times on a simulator. This is a very good example to show that we have run this scenario 100,000 times. When you drive, there is a butterfly effect. When I do, let's say I'm doing this double merge, 2-meter difference than the last time, everything is changing. All the cars behind me and in front of me are behaving differently. So every scenario has 100,000 times sub-scenarios. So we are able to do that already, teaching the algorithm to drive in a safe state, not having accidents, and doing the task with accuracy of a success of 99.95%. This is something that is being run on our algorithm constantly. Eventually, the autonomous car needs to drive here. This is not India. This is Europe. If the autonomous car were not able to drive in the middle of Paris, it will not be scalable. We will have no market. So, how safe is safe enough? Let's say Mobileye, very sophisticated company, now part of Intel. You have Google, you have Uber, you have Tesla, you have others. Who decide what's safe enough? Okay, so let's say we have an accident between an autonomous car and a human driver. We're going to send the police officer. So what? He will start to investigate the code of the car. So we came with an approach that allows us to drive safe but assertive. It cannot drive like my grandmother. It must drive assertively in the streets. It has to be transparent, useful, and affordable. So what we have come with, it's an approach to the industry. It's not the Mobileye algorithm. It's an approach to the industry that's saying, let's analyze all type of accidents. Let's put that in a mathematical formula, adding the human common sense of behavior into the mathematical formula, and set the rules of the game in advance. By using that, you can make sure that the autonomous car will never be the reason for the accident. You cannot guarantee that the autonomous car will never be involved in an accident, but you can guarantee that it will never be the reason, the cause of it. So what we have decided to put on top of the 3 layers, it's a mathematical formula. We took 37 types of accidents that were classified by NHTSA, the American Institute, and then we made sure in a mathematical formula that we formalized that. We define what is a safe driving in those 37 type of accidents, and by that we are able to avoid that the autonomous car will not be the reason for the accident. So you can see here, this is not inside the formula, but here, in this scenario, you are able to do that. The AI technology, which is based on data and deep learning and machine learning, must be transparent to the regulators. How they will regulate autonomous cars if it's not transparent to them? So what we are doing, we are putting the RSS layer, the responsible sensitivity safety. This is our approach on top of the AI planning. By that, we are creating transparency for the regulators. So they understand, they can regulate, if you like, in other words, how the autonomous vehicle shouldn't behave, never, ever, instead of regulating how the autonomous car should behave. And this is much easier approach, it's much more transparent approach to the industry. Currently, we work with the EU, all the main governments, the Chinese, the Americans, the Germans, the Japanese, on this formula, which is very well adopted by the industry and by the regulators so far. So this is scenario from an autonomous car. You can see here the car, and here you can see we have the detection by the sensors. We have the maps, okay? We have now a driving policy inside. Now the lane here is about to end. So the car must drift a lane, must. Otherwise it will go to the ditch. It has to be assertive. So you can see here that the car is doing an assertive, human-like behavior. Otherwise it will go outside of the road. Another scenario, you can see here that the car is now trying to drift a lane, again in an assertive way, near human drivers. The humans that are driving here don't understand this is a robotic car. They are not able to see the differences. Another scenario, you can see a tractor. Now, if it's a traditional robotic car, it will stop here. But now the car tries to move on, waiting. Again, they don't let her pass, but now, eventually, the car in an assertive way goes there, calculating the roads, using the sensor, the map, and the RSS, what is a safe enough state to do it. We humans, we drive with assumptions. When I'm drifting a lane, my assumption is that the driver behind me will slow down. And our software does that also. So the situation is that currently in Jerusalem, we have started the driving. We have around 13 different projects. I talked about BMW, but we have a few more. So we have around 10 vehicles currently driving in Jerusalem autonomously, absolutely autonomously. Also in Santa Clara in the summer, in the US, California, we're going to launch 30 more. Until the end of the year, we will have almost 100, and we are moving very fast towards the autonomous vehicle. It's coming soon. Sorry, I know some of you. I saw a paperwork by Deloitte in the US saying that until 2050, it will not be allowed to drive. I told them, don't bring it to Germany. So let's go back to reality. Safety. Who needs that? Why? It's needed. Here is a study made by AXA Insurance in Switzerland saying that before the autonomous car, before automatic braking, before everything, only alerting the human driver, you can prevent almost all the accident if you give a good alert before the time. We are doing that. When you use the Mobileye ADAS solution, retrofitted or coming from the factory, from the OEMs, the chance to have a collision reduces by around 50%. This is our statistics. With 27 million vehicles, We have retrofitted 1.5 million vehicles. Our approach always, what we are developing for the future, we are using today as a retrofitted solution. But Mr. and Mrs. Muller in Germany don't buy safety. And Mr. and Mrs. Israeli in Israel don't buy safety. They are good drivers. The others are bad. So if I give an average person in those countries $1,000 voucher, and I'm telling you, you can put the best and the most advanced technology to avoid collision, or a Bose multimedia system, 95% of them will choose the Bose multimedia system. This is the truth. That's why we at Mobileye work a lot with regulators. And until the government will start to force or to mandate or to incentivize the industries inside the countries, we will not have safety features in most of the vehicles. You can see in Europe, you can see the slide I've prepared for you to show you where Europe is standing in front of the rest of the industry. So you can see that in China, Korea, Japan, things are happening much faster than in Europe. The technology exists today. We can detect pedestrians, I just showed you, 99.99% accuracy. Why to wait until 2022, 2024? You know how many people can be saved? And if it takes time to implement that in new vehicles, you can retrofit this technology. So some of the governments already understood that. So you can see regulations in many countries that are already talking about the existing vehicles. Because today, this year, 2018, around 75% of the new vehicles in Germany will be sold with no safety features at all. And they will remain on the roads for the next 10 years. And next year, and last year, and 2016, etc. So our ability to detect pedestrians and to detect cyclists and to detect vehicles are enabling all those features that some of you are already driving with. Lane detection allows us to do lane departure warning, vehicle detection, automatic braking, traffic jam assist, pedestrian detection, automatic braking and warning the driver, and the traffic sign recognition, animal recognition, and general object. Those are retrofitted solutions that are using the same technology that we are selling to Audi and BMW and Volvo and Mazda and all of those guys, can be retrofitted on every existing car with all the features. 40 and 50 minutes of installation. I take a Renault Clio from 2004, and they have the best and the most advanced technology to avoid collision. I'm repeating myself, 50% in average reduction in accident, and I'm saying 50% because my legal department doesn't allow me to say more. The actual numbers are bigger. So you see that in our retrofitted solution, we can also detect all the objects, the same as I show you for the autonomous car. I'll jump. The biggest fleets, I said Mr. Muller and Mr. Israeli don't buy safety, but fleets are buying safety because they understand. Why they understand? ROI. This is what they understand. Reduce return on investment. So when you reduce accidents, there are less costs. So you can see the biggest fleets in the world that are retrofitting those solutions if it doesn't come from the factory. Recently, we just signed, I understand there are many energy companies here. We have signed an agreement a few weeks ago with Schlumberger, retrofitting our solution all over the world. They started in America. They have around 70% reduction in accident. CR England having 37% reduction in accident. Transgourmet here in Germany are retrofitting it and doing that now in all of their fleet. I'll pass. We can use this technology as a smart city or let's say a generic smart city solution. In the US, by the way, we won the Smart City Challenge by the US federal government in Columbus, Ohio, using the Mobileye technology, because what is a smart city if it's not a safe city? You want to be the city smart, you want more people using bicycles, you want more people using alternative transportation, not using their vehicles, but they are exposed to long vehicles, buses, and trucks inside the cities. And in London, for example, every week, cyclists are being killed. So they came to us, the City of London, a few years ago, and asked us if we can provide them a solution upon our ability to retrofit technology and to detect pedestrian using only a vision sensor. We came with this solution. I would like to show you in a 2-minute clip how it looks like.
Weltweit werden jedes Jahr über 600.000 ungeschützte Verkehrsteilnehmer bei Verkehrsunfällen getötet, viele von ihnen durch Unfälle mit Nutzfahrzeugen und Bussen. Die meisten Unfälle zwischen Nutzfahrzeugen und Straßenverkehrsteilnehmern geschehen aufgrund der toten Winkel, die sich um die Fahrzeuge befinden. Diese toten Winkel stellen beim Abbiegen eine erhebliche Gefährdung dar. Mobileye Shield Plus ist eine revolutionäre Sicherheitstechnologie für Nutzfahrzeuge und Busse in urbanen Gebieten, um eine Früherkennung von Fahrradfahrern und Fußgängern zu ermöglichen und Unfälle zu vermeiden. Durch die Nutzung einer Reihe strategisch angeordneter künstlicher Smart-Kameras fungiert Shield Plus als drittes Auge des Fahrers, indem es kontinuierlich die toten Winkel überwacht. Shield Plus liefert optische, akustische sowie Vibrationswarnungen in Echtzeit, wann immer ein Fußgänger oder Fahrradfahrer sich in einer Gefahrenzone befindet, sodass dem Fahrer ausreichend Reaktionszeit geboten wird. Durch die Nutzung der intelligenten Technologie für künstliches Sehen, welche die dynamische Fahrumgebung analysiert, reduziert Shield Plus mögliche Fehlalarme, da unbewegliche Objekte nicht erfasst werden. Shield Plus ist mit einem Telematiksystem verbunden, welches die Orte der Warnungen aufzeichnet und so Entscheidungsträger mit Echtzeitdaten über Gefahrenpunkte der Infrastruktur, sogenannte Hotspots, versorgt. Damit wird ihnen erstmalig ein Werkzeug an die Hand gegeben, Verbesserungsmöglichkeiten zu erfassen, um das Unfallrisiko senken zu können. Die revolutionäre Technologie von Shield Plus erschafft eine intelligentere urbane Umgebung und macht unsere Städte für alle sicherer.
So this solution is being very well accepted all over the world. In Germany, we're a little bit struggling, data and stuff, but yet you can see that we are measuring city behavior. The data, of course, it's fully anonymized. We don't care which car went, but if you have 10 buses driving at the same junction, getting the same type of alert, you have a problem with the infrastructure. And this is something that is being adopted in those type of cities. In Düsseldorf, it's the only city in Germany yet. In Berlin, we are doing a pilot, so I said I'm in Berlin, I'll write Berlin. But the truth is that you have cities here in Europe that you cannot drive a long vehicle without this type of technology. Game over. The technology exists. The only need is to take decisions, that safety is important. So I just said that we are able to, using the technology that we have developed for the autonomous vehicle today. So we have launched in Düsseldorf, and now we are doing that in many cities. I'll show you, collecting the data for the autonomous vehicle, but this is also can be used for smart cities. Because if I mapped Tel Aviv or Berlin, I can send the data to the city hub of Berlin. What is the status of the infrastructure? I have a vision sensor that understands that. What is the traffic sign status? What is the traffic itself status? I can do that in real time. So, as I said, we harvest, we aggregate, and then we send the data not to the autonomous car, we send it to the city hub. And jumping there, showing bad infrastructure, even parking applications. we can understand where are there empty parking spots. And the cars are using that anyway. So here you can see as an example, we have created an API with a company named Esri, which sits as a GIS platform in most of the biggest cities of the world. They know how to take the Mobileye outputs from the smart vision sensors out there and to analyze the data and to bring decision-making possibilities to the decision makers of the cities. Those are the cities that we are starting to do mapping for autonomous ready, making them autonomous ready. With no HD maps, there is no autonomous car. Vielen Dank.